Hi, this is Martin Brennand, Product Manager from Imagineer Systems. Mocha has always been known for its delightful planar tracking and rotor tools for solving all sorts of visual effects problems. With Mocha version 3, we're introducing a range of great new workflow enhancements, but one of the biggest requests from users was the ability to convert Mocha's 2D planar tracking data into 3D space. We've seen many cases previously where artists have used Mocha to help with 3D tracking. By using Mocha's planar tracker to insert grids and texture into a shot, artists could then use a 3D feature tracker and other software to finish doing a solve. So we thought, why not cut out that extra step? This is where the camera solver in Mocha version 3 comes in handy. First thing first, let's talk about what the camera solver is not. Mocha's camera solver is not trying to replace the big 3D trackers out there. What we are providing is a simple alternative to track your shot and get a camera for your needs. Mocha's camera solver is taking your 2D planar tracking data and working out how a camera would be moving relative to those tracked planes. This means you get the accuracy of a planar tracker to handle the blurry shots and the objects that move out of frame to solve your camera. Mocha is giving you a camera based on the planar information you have tracked in the shot, which is all you need for many types of visual effects shots. We don't go as far as creating a complete physical accurate model of the scene. Many camera trackers will give you a point cloud of information. We think simplicity is best and give you nulls and axis points representing the planes you have tracked. In this video, I will be covering the different types of camera solves Mocha offers and give you a little glimpse into the sort of work it can do for you. Before we delve into working with the different types of camera solves, let's take a quick look at what they are. Under our camera solve in Mocha, we have a camera drop-down inside the 3D motion section. If we click on this, we have 4 different options to choose from. We have Auto, which lets Mocha guess the type of camera solve it needs to do. We have Pan Tilt Zoom, which is a fixed camera that only has rotation and zoom and no XYZ translation. We have Small Parallax Change, where the camera is only moving slowly over a short distance relative to the subject. And Large Parallax is used where there is a large amount of XYZ camera translation relative to the subject. So let's start off with a nice easy example using Pan Tilt Zoom. Here we have a shot from SVT on the show Real Humans. I'm going to just track the pan in this shot by finding a plane in the scene and then solve the camera for that pan. So this wall is a nice place to start, so I'm just going to draw a nice easy big shape around that plane in the shot. Like so. I'm just going to tighten it up a little bit so this guy in the yellow doesn't ruin my track. And then I'm going to turn on perspective to track the perspective in the shot. And I'll set the minimum percentage of pixels up to about 90, just so that we get as much detail as possible. So let's just zoom back into that shot a little bit. Let's use my Z key and draw it back in. And so we're just going to track this shot quickly before we do our camera solve. So if we turn on our grid, we can see how that plane is being tracked through the shot as normal in the 2D process for Mocha's planar tracker. Once we have our plane tracked, we then can switch over to the camera solver. Inside the camera solver, we could automatically choose the Auto option, but in this case we know it's a Pan Tilt Zoom, so I'm going to just choose that. So we just select the Pan Tilt Zoom option, and then we can set our focal length. In this case we know it's a 35 to 70mm, so I'm just going to leave that plane as it is. I can then click Solve, and we can see how quickly that gets solved for Pan Tilt Zoom. It's already done. We can now export out the camera data to whichever application we need. In Mocha AE and Mocha Pro, you get Mocha for After Effects 3D motion data to copy to the clipboard. This actually comes with a 3D plugin that comes into After Effects, and this is free with the Mocha Pro and Mocha After Effects versions. So you'll get the standalone version of Mocha, plus a plugin to go into After Effects whenever you buy the product. So we're just going to copy that to the clipboard and then switch over to After Effects. Over in After Effects we have the footage ready to go, so we just need to come up to the Edit menu and choose the Paste Mocha Camera option, similar to how you would paste a Mocha mask or actually paste in tracking data when you're transferring it over from Mocha. So this Paste Mocha Camera option will only exist when you put the free Mocha plugin that you get with Mocha Pro and Mocha for After Effects version 3. So we'll just click on that, and then we get a Mocha camera. You can see in here that we have 5 separate nulls within the shot. These nulls represent the surface that we had inside Mocha. So if I just switch back to Mocha for a second, in Mocha, if we just turn off the grid for a moment, I'm going to show you the surface here. So these surface corners are represented inside After Effects with individual nulls. So we have one corner for each, and we have a central point. This helps you define the plane within the scene. Back over in After Effects, you can see how those nulls are set up for that surface. And each of those are just set up facing the camera when you're doing a pan-tilt zoom. Because we're doing specifically a pan-tilt zoom, we're only looking at the plane of the camera, so we don't have positional data for these nulls in depth. So they will stay at the same depth, but they will move according to the plane of the camera because the camera is moving. So if we look at our two views down here, we can select our camera and you can see that camera in the shot. So if I drag through the timeline, we can see how that is moving with the camera, but the null stays stationary because it defines the plane of the camera at its initial point. So once you've got your camera in there, and I'll just switch back to my one view, we can then insert 3D objects as we need. So in this case, I'll just show a simple example. I'm going to create a solid and come up to my effect here, and let's just create a simple BCC extruded text from Boris plugins. So we'll just put in Mocha. And then let's just quickly set up a few parameters here. So under the extrusion in the Boris plugin, I'm going to set this depth to 10. I'm going to get rid of that bevel. And I'm going to choose to use the comp camera. And you can see how that starts to push out from the camera that we've already defined. So now if we press play, we can see that Mocha 3D object is actually moving with the camera as you would expect. And then, of course, we can add extra lights as we need. So if I went back to my 2D view, I could add a light up here, so new light source. Let's just go with a point light and get the relative light from the scene. Let's just go for something over here. Oops, a bit too light. 100. And then we'd probably put that behind it a little bit and maybe move it up slightly. So we've defined a 3D model in the scene, we've defined a light in the scene, and it's all working from that simple pan track that we solved inside Mocha. It's really that simple. For Mocha Pro users, we also have the ability to export out to FBX. We provide two different versions just to handle the FBX a little bit differently. So we have a standard FBX format that will export out to things like Cinema 4D and Maya, and we have a Nuke version to handle the way Nuke reads FBX inside its version 6.3. In this case, let's just show a quick example exporting out the FBX for this layer. So I'm going to choose that version and click Save. And then I'm going to quickly write that out. So I'm just going to call this pan track and click Save. Over in Cinema 4D, I can then just open that or merge that FBX into the shot. So I'm just going to find the source file and click my pan track. And then we have a bunch of FBX import settings. Click OK. I'm going to choose the frame rate of 25 because that's what the frame rate was in this shot. And then we get our camera and the points, individual accesses for the plane that we set up inside Mocha. So when we actually run this timeline through, you can see that camera moving through the shot. Rather than take you through the entire process of inserting models, I've just quickly set up a scene here, inserting a telephone box into this shot. So I've got my 3D model, a few lights, and the camera data that I set up from Mocha. Now let's look at a slightly more complicated version of the pan-tilt zoom solver. In this shot we have quite a large turn, almost 60 to 90 degrees. Because we were looking for planes within the shot, we need to create more than one layer to build up a couple of planes to help solve the shot. So first of all, I'm going to try and solve as much of the turn as possible with an individual plane. So I'm going to select a plane around this area, and turn on my perspective again, and I'm going to make it as solid as possible with about 90% of the pixels, and start tracking that shot through. As always, if we turn on our grid, we can see how that plane is going throughout the shot. When we see this grid turn more than it needs to, or actually goes out of the shot, it's useful to actually draw another plane to help work with it. So now that we can see this plane has turned quite a significant amount, we're going to add another plane to help the rest of the track. This is very important to understand. When you actually want to draw another plane to assist your camera solve, you need to make sure there is some overlap in the track you've already done on another plane. So here we can see that we've already tracked this blue section of the timeline. I'm going to move my timeline playhead back to a certain point, so there's enough overlap between what I've already done and the new layer that I'm going to create. So now we can come up and draw another shape. I'm just going to draw a shape around here where we get some more detail. And once again, I'm going to turn on perspective and set my value to about 90. Just so that I know where this layer is starting, I'm also going to set my in point to the point where I drew it on the timeline. Very important too is to remember to actually turn off the layer that you've already been tracking so you don't track it anymore. So I'm just going to turn off that. And I'm going to call this one Pan 01, and we'll call this one Pan 02. So now let's start tracking with this layer selected. So once that's tracked, we now have two separate pieces of information to help with the solver. So we have a large pan track here for this section, and we have another large pan track here for the first section. Once we have both our tracks done, what we need to do then is select both our layers for the camera solver. So with one selected, I'm just going to hold down Shift, or you can hold down Control, and just select both of those layers within the timeline. Once we have both layers selected, we can come over to the camera solve and start doing our solving. So I'm going to choose Pan Tilt Zoom again, and leave the settings the way they are because that's the right ones, and I'm going to click Solve. You can see it's still pretty fast with Pan Tilt Zoom, even with multiple layers. And then we can go ahead and export our camera. Once again, I'm going to choose After Effects 3D Motion Data and copy it to the clipboard. So here we have the final pan inside After Effects. You can see how the 3D model is panning correctly within the shot, and we can also see the 5 nulls per layer that were created with the Mocha camera solver. So we still get individual points for each layer for the shot. 5 in total, the corners and the center points. Fixed cameras are all well and good, but we don't deal with those every single day. Quite often we're dealing with shaky, handheld, moving, panning, all sorts of different types of cameras. So this is where the parallax solvers come into play. Here we have a handheld shot that's quite shaky and moving down this corridor here. In order to solve a shot like this, we can't rely on the pan tilt zoom because our camera is no longer fixed down. To solve a parallax shot, we need to know how the camera is actually moving through 3D space. In order to work this out, we need to tell Mocha that there are at least 2 different types of planes within the scene. So in this case, we have a ground plane that has been tracked throughout the whole shot, and we also have a wall plane that is non-coplanar to the ground plane. Non-coplanar is just a fancy way of saying not on the same plane. So this plane and this plane are not on the same plane, and this plane and this plane are not on the same plane. Even this plane back here on the building behind is at a different Z depth to the plane in front, and so they are also considered not to be on the same plane or non-coplanar. Now that you've heard me say plane 17 times, let's just quickly go through the rest of the shot. I've only chosen to do 4 tracks in this particular shot, just to give me as much information as possible. I could of course chosen to do actually more tracks around, just to give myself solid data, like this wall over here, and this wall here, and the front ground here, and even this wall next to the door, but I've chosen to keep it to a minimum. You can add as many planes as you like when you're trying to track, but you want to try and get a good, even amount of different coplanar areas in the shot. So once I've tracked my non-coplanar areas, I then want to select all of the layers in the scene, go to my camera solver, and choose the type of parallax that it is. Now sometimes with large and small parallax solver, it's actually useful to choose auto, because sometimes it is difficult to work out which type it is. In this case, however, I'm going to choose small parallax because I know it is a small parallax solve. We've got a very subtle change between the midground objects here, and so we can get away with doing a small parallax solve in this instance. So I'm just going to click Solve and let that run. Parallax solves do take a little bit longer because there's a lot more calculations they need to do. Once we have a camera solve, we can then choose our export camera data again and export out to the application we need. In this case, I'm going to export out to Nuke to show you an example within there. So we'll just save our file, and we'll just call this small parallax FBX, and then we can switch over to Nuke. Over at Nuke, I've got a very simple scene set up here with just the camera and a simple scene, and we're going to load our FBX data into the camera. So I'll just double click my camera, and we'll say read from file, go to our file tab, and go and find the FBX that we saved inside Mocha. When it asks you if you want to destroy the camera data, you choose yes. And we set the correct frame rate from what it was. In this case, it was 25. Same goes for the regio. The regio is just the points that will be in the shot from the corner points in the surfaces from Mocha. So if we choose our file again, and we'll navigate to the same directory, I'll choose my small parallax here. I'll make sure my frame rate is 25, because that's what it was. And I'm going to choose point cloud. And we can see our surface points come into the shot inside the viewer. Then when we play back, you'll see how that camera data is moving through the shot with those planes calculated in 3D space. If we look at the 3D view, you can see how those planes are arranged in 3D space with the camera. If I drag my camera through, you can see that camera walking along like the handheld does towards the planes in the shot. This means it's now easy to position and place objects within the shot to do more 3D work for the composition. Because we now have those markers where the planar data is, it's very easy to insert 3D objects within your shot to align them correctly to the scene and the camera. We can see this through our 3D view here, that I've just placed my car on top of the first set on the ground plane, and I'm able to easily line it up for the camera to view it from the best angle. Finally, Mocha has a way to solve for moving objects within a shot by tracking the camera data for the static areas in the shot first, and then being able to export out a track for the moving object and solve for that area. So this is a shot by BFX Imageworks. We're doing a camera solve here for a large parallax shot because we've got a very fast moving foreground area and obviously a slower moving background area. So we're going to take this shot and we're going to solve it for large parallax, just for the static areas, and then come back in and track the moving object to bring that 3D data into After Effects. So first of all, I'm just going to quickly solve the shot for these 3 layers. So I'm going to select all my layers like I did before, go to my camera solve and choose large parallax, and then we'll click the solve button and come back. Okay, now that that's solved, I'm going to go to the Export Camera Data button and choose After Effects 3D Motion Data and copy that to the clipboard to bring into After Effects. Over in After Effects, we've got the scene set up here, so I'm just going to go to Edit, Paste Mocha Camera, and that will paste in our camera data for those 3 layers we solve for large parallax in Mocha. So we can see our 5 nulls again for each of the layers. If we drag through the shot, you can see how those follow along with those rocks. Now that we've solved for the static layers in the shot and got our camera, we can now solve for a moving object inside Mocha by tracking an area and exporting it out. Back inside Mocha, we can now go ahead and track our moving object. You don't have to track the moving object after you've done your static solve. You can actually track everything beforehand, but you just need to make sure that when you do the first initial camera solve that you only select the static objects when you do solve and then the moving objects afterwards. So let's track this tank. I'm going to just draw a large area around the tank top here, like so, And we're going to set that to perspective. I'm going to turn on my grid so I can see how this is looking. And we'll start tracking that forwards. So once it's finished tracking, we can now just check to see how that track is looking. And it's looking pretty solid. So now that we've got this single motion track, and I'm just going to call this tank, we can now export out this new track data as a moving object inside the camera solver. So we don't select any of the static layers that we've already solved for the camera, and we just select the moving layers that we need to export, that we want to move inside our composition. So I'm going to just choose Export Camera Data. I don't need to solve, just Export Camera Data, and copy that to the clipboard. Back over in After Effects, we just come to the top of the stack, and we can go Paste Mocha Camera again, and a new set of layers will appear inside the composition with the nulls positioned where we set them in Mocha for the track. It will bring in a secondary camera, and you don't need to use this if you don't want to, so we can just get rid of that. So now what we have is, if I select these nulls, is a series of animated moving objects in 3D space. These will follow along with the object we tracked in Mocha, but in the correct position and depth for the camera solve that we did earlier. So that wraps up this overview of the 3D solver for Mocha version 3. If you want to find out any more about how the process works in the 3D solver, please check out our documentation in the software. If you have any questions, please visit our forum online at forum.imagineersystems.com or come to our Facebook page at facebook.com/imagineersystems. We also have a Twitter feed at imagineersystem, or you can check out our blog at blog.imagineersystems.com. This has been Martin Brennand for Imagineer Systems.